Former NASA Administrator Bill Nelson recently voiced his concerns over significant changes at the agency, particularly in light of recent layoffs and policy shifts that could jeopardize its Earth science programs. Speaking at the Kennedy Center's Earth to Space Festival on March 29, Nelson highlighted the dismissal of NASA's chief scientist and chief climate officer, a move he believes reflects a troubling trend. "I have to say that the first person that was fired at NASA was the chief scientist and chief climate officer, and so I think we need to be concerned about that," Nelson stated, emphasizing the need for vigilance in the face of changing leadership priorities. NASA's recent restructuring includes the closure of its office of the chief scientist alongside other divisions focused on technology policy and diversity. This reorganization has affected 23 employees, including Kate Calvin, who had served as chief scientist since 2022. The ramifications of these changes are particularly alarming for those in the scientific community who fear potential cuts to Earth science programs as the agency prepares its budget proposal for fiscal year 2026. Reports suggest that NASA's overall science funding could be slashed by as much as 50%, a drastic reduction that could stifle critical research. Nelson, who has long championed the importance of Earth science at NASA, reiterated the agency's role in fostering stewardship of the planet. "Is it important to us that we know so that we can be better stewards of what we have on this extraordinary planet?" he questioned, suggesting that political influences may be interfering with scientific integrity. While expressing concern, he acknowledged that compared to other government agencies, NASA has thus far managed to avoid more severe repercussions, such as widespread layoffs of probationary civil servants. He also praised Janet Petro, NASA's acting administrator, for her efforts to mitigate larger cuts and maintain focus on upcoming missions such as Artemis II, scheduled to launch in the next year. However, Nelson noted that anxiety continues to simmer among current employees regarding the possibility of further layoffs and structural changes. In the wake of these developments, Nelson expressed unease over what he termed political interference. He referenced comments made by NASA's press secretary Bethany Stevens during a recent interview where she claimed that the successful return of astronauts Suni Williams and Butch Wilmore was a significant achievement for the Trump administration. Nelson countered this assertion, clarifying that the decision for the Crew 9 mission had been made by NASA well before the recent election cycle, asserting, "Of course, none of that is the case." Amidst these challenges, NASA remains engaged in groundbreaking research, with the Curiosity rover's latest findings on Mars capturing attention. The rover detected the largest organic molecules yet found on the planet, a discovery that could provide crucial insights into the potential for past life on Mars. These molecules, including long-chain hydrocarbons, may hint at the biological processes that once occurred on the planet, reigniting interest in Martian exploration. As NASA navigates the complexities of its internal changes and the broader political landscape, the agency's future direction remains uncertain. Nelson's insights underscore the delicate balance between scientific inquiry and political influence, signaling a critical time for NASA as it endeavors to uphold its mission of exploration and discovery. The coming months will be pivotal as the agency prepares for significant missions while grappling with the implications of recent leadership transitions and budgetary constraints. As the world watches, the outcome of these developments will shape not only NASA's trajectory but also the future of space exploration and our understanding of Earth's climate. NASA astronauts Suni Williams and Butch Wilmore have found themselves on an unexpected extended stay aboard the International Space Station ISS, lingering in microgravity for nearly a year, far beyond their initial mission timeline. This prolonged sojourn has stirred not only a sense of adventure but also a longing for the simple pleasures of life on Earth, particularly the experience of weather. "I actually really do miss the weather," Williams shared during a live interview from the space station. "I'm looking forward to feeling all that weather from Earth." Their journey began with a test flight of Boeing's Starliner spacecraft on June 5, 2024, intended to last just a few days. However, after encountering a series of technical challenges, NASA made the cautious decision to keep Williams and Wilmore in orbit while Starliner returned to Earth uncrewed. This unexpected turn of events has allowed the astronauts to delve deeper into scientific experiments and share unique experiences such as baking cakes and enjoying the stunning visuals of Earth's weather patterns from above. Williams remarked on the fascinating spectacle of thunderstorms, noting, "We see a lot of lightning," yet she emphasized the stark difference between observing weather phenomena and experiencing them directly. Life aboard the ISS offers a consistent environment. Temperatures are maintained at a comfortable 75 degrees Fahrenheit with humidity levels around 40%. In stark contrast to the varied elements of Earth, the only wind experienced is the artificial breeze from fans or the gentle push of microgravity. Wilmore expressed his yearning for the sensory experiences of Earth life, saying, "You kind of miss the smell of fresh cut grass. And those types of things that just you kind of take for granted." As they prepare for their anticipated return on a SpaceX Dragon spacecraft later this month, the astronauts reflect on their unique journey and the lessons learned during their time in space. "Of course, we came up here thinking we'd be only here for a little while and do our test flight, but then the added time here has allowed us to do all the science experiments," Williams noted. "We've gone through a lot of holidays together." Wilmore encapsulated the essence of their mission, stating, "Opportunities for the betterment of mankind is what all this exploration is about. To be able to take part in that, especially in such a wonderfully special place like this, is just a blessing." Their experiences highlight the personal sacrifices and unexpected joys of life in space, offering valuable insights into the human spirit's resilience and adaptability amid extraordinary circumstances. As the space industry gears up for a busy April with multiple missions planned, including SpaceX's upcoming exploration of Earth's polar regions and NASA's Tracer's mission to study space weather, the return of Williams and Wilmore marks a significant milestone. Their extended stay not only underscores the challenges of space exploration but also serves as a reminder of the importance of adaptability and the human connection to Earth. In the coming months, the insights gained from their experiences aboard the ISS may inform future missions and contribute to our understanding of life beyond our planet. In an unprecedented space saga, NASA astronauts Butch Wilmore and Suni Williams have returned to Earth after a remarkable 9-month stay aboard the International Space Station (ISS). Their journey, originally intended to last only a week, became a prolonged odyssey due to a series of technical complications with Boeing's Starliner spacecraft, which ultimately delayed their return until March 18, 2025. This episode not only tested the astronauts' resilience but also highlighted the complexities and challenges of human spaceflight. Wilmore and Williams, along with fellow astronaut Nick Hague, participated in a news conference at the Johnson Space Center in Houston on March 31, where they recounted their unexpected experiences. "My first thought was we just got to pivot," Williams said, reflecting on the need for adaptability in the face of unforeseen circumstances. Their mission began on June 5, 2024, when they launched from Cape Canaveral Space Force Station, but soon after docking with the ISS, the Starliner faced thruster malfunctions that made an immediate return unsafe. The astronauts' extended time in microgravity has had significant physical implications. Deanna Wilmore, Butch's wife, shared that he is currently grappling with muscle weakness and bone loss, common after long-duration spaceflight. "His stamina isn't there and they have to rest and relax quite a bit because they're just not strong yet," she noted, underscoring the rigorous rehabilitation process that awaits. Experts warn that astronauts can lose up to half their muscle mass and 20% of their bone density during extended missions, which necessitates a comprehensive recovery strategy. NASA has scheduled 45 days of intensive rehabilitation for Wilmore and Williams, focusing on core strength and mobility training to help them readjust to Earth's gravity. "Nothing completely prepares you for Earth's pull," stated spine expert Dr. Ehsan Jazini, emphasizing the challenges that even seasoned astronauts face upon returning. Remarkably, both Wilmore and Williams managed to walk within 24 hours of their landing, a feat that is often difficult for astronauts newly returned from space. As their physical recovery begins, the personal aspects of their return have also come to light. The emotional reunion with their families was heartfelt, with Deanna recalling, "It was just a lot of hugging and enjoying the moment. Wilmore's family, including his daughters, were present to celebrate his homecoming, marking milestones that he nearly missed during his unexpected absence. In addition to the physical and emotional hurdles, the astronauts faced financial questions regarding their extended stay. While astronauts are generally salaried employees, they receive additional compensation for time spent in space, an arrangement that is more akin to federal travel allowances than traditional overtime pay. Estimates suggest that Wilmore and Williams could earn several $1,000s in incidental expenses due to their prolonged mission, as the world celebrates their safe return. The experience of Wilmore and Williams serves as a poignant reminder of the unpredictability of space exploration and the human spirit's capacity to adapt and overcome. Looking ahead, their journey will not only contribute to our understanding of how the human body reacts to long-term spaceflight but also inform future missions as NASA continues to push the boundaries of exploration. With ongoing advancements in space travel technology and the lessons learned from this unique experience, the future of human spaceflight appears both exciting and challenging. In a remarkable intersection of nature and technology, scientists have recently unveiled significant findings regarding the expansion of mangrove ecosystems along the U.S. East Coast. This research not only highlights the resilience of coastal flora but also underscores the broader implications of climate change on these vital ecosystems. As mangroves increasingly migrate northward, they bring with them a host of ecological benefits and challenges that warrant attention. Historically, mangroves have thrived in the warm tropical climates of the southern United States. However, a groundbreaking study published in March 2025 reveals that red mangroves Rhizophyra mangle and black mangroves Avicennia germinans have been discovered growing significantly farther north than previously documented. Specifically, researchers found these species thriving 50 miles and 14 miles respectively beyond their known range near the Florida-Georgia border. This marks the first recorded instance of naturally occurring mangroves in Georgia, representing a noteworthy shift in their geographical distribution. The research team conducted field surveys in tidal marshes and supplemented their findings with satellite data from the operational land imager 2OLI-2 onboard Landsat 9. This satellite imagery, captured on March 11, 2025, provided a comprehensive view of the mangrove habitats and their transition from salt marshes. Although the young plants were too small to be detected visually in the imagery, the data has proven invaluable for monitoring long-term changes in these ecosystems. Cheryl Doughty, an assistant research scientist at NASA's Goddard Space Flight Center, explained that the favorable conditions along the U.S. East Coast, characterized by less frequent extreme cold events and rising winter temperatures, have contributed to the survival and expansion of mangrove trees. If they are lucky enough to settle in the right conditions, they may establish, Doughty noted, emphasizing the adaptability of these species to shifting climatic conditions. The Gulf Stream plays a crucial role in this expansion by facilitating the movement of mangrove propagules, small specialized seedlings that can drift with tides and currents. According to Doughty, these inlets are like safe havens from oceanic forces, allowing these propagules to anchor in salt marshes and establish new populations in previously unoccupied territories. However, the implications of this northward migration extend beyond mere botanical curiosity. As mangroves establish themselves in new areas, they enhance ecosystem services such as carbon storage and coastal protection. The ongoing shift in mangrove distribution highlights the need for scientists to track these changes closely, as they are indicative of broader ecological transformations driven by climate change. In conjunction with the field survey, satellite data will continue to play a critical role in monitoring these transitions. Consistent, trustworthy, and accessible satellite data make monitoring the rapid changes of Earth's surface possible. Doughty stated, "The integration of ground observations with satellite imagery will be essential for understanding the long-term implications of mangrove expansion and the associated changes to coastal ecosystems." As researchers continue to explore the dynamics of mangrove ecosystems, the findings serve as a reminder of nature's resilience in the face of climate change. The northward migration of these coastal trees may signal both an opportunity for ecological restoration and a challenge to adapt to shifting environmental conditions. Moving forward, the scientific community will be keenly observing how these critical habitats evolve and what measures can be taken to protect them in a rapidly changing world. NASA's Perseverance rover, which landed on Mars in 2021, has become a cornerstone in the agency's quest to prepare for human exploration of the Red Planet. While its primary mission includes searching for signs of ancient microbial life and analyzing the planet's climate and geology, it also carries a crucial component aimed at aiding astronauts' future missions: samples of spacesuit materials. These materials have been subjected to the harsh Martian environment for over 4 years, providing invaluable data that will inform the design of the spacesuits worn by potential Mars explorers. The aim of this study is to accurately predict the lifespan and durability of spacesuits on Mars, a necessity given the planet's extreme conditions. Mars presents a challenging landscape with sub-zero temperatures, abrasive dust, and high levels of solar radiation due to its lack of a protective magnetic field. As materials scientist Razel Hollis, who worked on the rover's Sherlock scanning habitable environments with Raman and luminescence for organics and chemicals tool, points out, understanding how materials decay on Mars is critical. He draws a parallel with how white plastic chairs deteriorate under prolonged sun exposure, emphasizing the need to ascertain how quickly spacesuit materials will wear out. Among the samples carried by Perseverance are various fabrics, including Vectron, a cut-resistant material used for gloves, and orthofabric, which combines layers of Nomex, Gore-Tex, and Kevlar for enhanced durability and protection. Each material will undergo rigorous analysis to determine how well they withstand Martian conditions, with an initial study indicating that around 50% of the changes in the samples occurred within the first 200 days of exposure. This research is not just an academic exercise, it has immediate implications for the future of Mars exploration. As NASA scientists simulate Martian environmental conditions in controlled settings on Earth, they aim to compare their findings with the data collected by Sherlock. This will allow for a comprehensive understanding of how much strength and flexibility fabrics lose over time, which is essential for ensuring the safety and effectiveness of future astronauts. In tandem with these efforts, NASA's Curiosity rover has made significant strides in the search for life on Mars. A recent discovery of the largest organic compounds ever found on the planet, decane, undecane, and dodecane, offers new insights into Mars's potential to support life. These fatty acids, crucial for cellular structures on Earth, suggest that Mars might have hosted a more complex prebiotic chemistry than previously assumed. The organic compounds were discovered in a rock sample from the Yellowknife Bay area, which scientists believe once resembled a lakebed, providing an environment conducive to life. The implications of these findings are profound. They support the theory that organic molecules can survive the harsh Martian conditions, including radiation and oxidation, which typically degrade such compounds over time. This preservation offers hope for future discoveries that could bring humanity closer to answering the age-old question of whether life ever existed on Mars. As NASA continues its exploration of the Red Planet, including plans for a Mars sample return mission in collaboration with the European Space Agency, the data gathered by both Perseverance and Curiosity will be instrumental in shaping the future of human exploration. The interplay between understanding materials for astronaut safety and the ongoing search for life forms a critical part of NASA's long-term vision for Mars. With each new discovery, scientists inch closer to unraveling the mysteries of our neighboring planet and preparing for the eventual human presence there. In a remarkable leap forward for lunar exploration and technology, the Department of Defense has successfully completed underway Recovery Test 12 in collaboration with NASA, marking a significant milestone in the United States' efforts to ensure safe and efficient operations in space. This achievement is particularly timely as both agencies intensify their focus on sustainable lunar missions and future human habitation on the Moon. The underway Recovery Test Series is designed to evaluate recovery systems for spacecraft returning from space. Insights gained from these tests will play a vital role in enhancing the safety and reliability of missions, particularly as NASA prepares for its Artemis program, which aims to send astronauts back to the lunar surface. The collaboration between the DoD and NASA is a testament to our commitment to exploring new frontiers while ensuring the utmost safety for our astronauts, said a spokesperson from the Department of Defense. In tandem with these developments, recent research into lunar dust has shed light on the potential hazards posed by the moon's surface materials. Historically, astronauts have reported adverse reactions to lunar dust which can cause respiratory issues and damage to equipment. A NASA study from 2005 highlighted that lunar regolith, the fine dust covering the moon, can adhere stubbornly to spacesuits and other surfaces, presenting significant challenges for long-duration missions. Recently, a Canadian experiment launched aboard Firefly Aerospace's Blue Ghost lander has been investigating dust mitigation techniques. Jacob Kleiman, president of Integrity Testing Laboratory, noted dust is one of the hottest topics in moon exploration, emphasizing the need to address this issue as NASA looks towards establishing sustainable lunar bases. The experiment involved two cylindrical wheels, each equipped with dust mitigation technology designed to reduce the electrostatic charge that allows dust to cling to surfaces. The data collected will be compared to ground testing results to further understand lunar dust properties and inform future missions. As NASA gears up for its Artemis 3 mission, which aims to return astronauts to the moon by 2027, the focus on dust management has never been more critical. With timelines still tentative and technologies under development, the integration of advanced dust mitigation strategies could be pivotal in ensuring the success of these ambitious plans. Meanwhile, innovation is also brewing in the commercial sector, with companies like Lone Star Data Holdings pioneering the concept of off-Earth data storage. Following the launch of their 8-terabyte data center to the moon, the company has drawn parallels to the Wright brothers' historic flight, heralding a new era in data security. Chris Stott, founder of Lone Star, stated, "Just as aviation revolutionized travel in the 20th century, we are poised to revolutionize data storage and security in the 21st century." The company aims to leverage the moon's relative safety from terrestrial threats to store invaluable data, addressing the rising concerns over digital information loss. The implications of these advancements are profound, as they not only signify a resurgence in lunar exploration but also highlight the integration of public and private efforts in space. Florida, home to NASA's Kennedy Space Center, is at the forefront of this new space economy, attracting significant investments and fostering an ecosystem of innovation. As the lunar landscape evolves, so too will the technologies and strategies we employ to navigate it. The challenges posed by lunar dust and the opportunities presented by commercial ventures are just the beginning. With ongoing research and upcoming missions on the horizon, the next few years promise to be transformative for humanity's endeavors beyond Earth. As we continue to push the boundaries of exploration, the moon stands as both a destination and a proving ground for the technologies that will define our future in space.